All right, sixth graders, in lesson 10.1, we're talking about rational numbers. So who can tell me again what's a rational number? How do you define a rational number?
Numbers that can be written as a fraction.
Good, numbers that can be written as a fraction. So they give us an example in a book, A over B, because that can be any numbers. A could be any number, B could be any number except for 0. B cannot be 0. You can't have a 0 in the denominator. All right? Now, if we're given some integers, we can write them as rational numbers. We can write 5 as 5 over 1 to write it as a rational number. Or negative 3 as negative 3 over 1. Or we did some on your assignment. We did 19 over 1. We did negative 4 over 1. You can write fractions and mixed numbers as rational numbers. So if it's a mixed number, how do you change it to a top-heavy fraction again? Danny?
Times the
The whole number times the bottom number. That's called the denominator. Plus the numerator. And then write the whole number over, write that answer over the what? Over the same denominator. Sophie? Right? So the denominator is 4. And so you write the answer over 4. Yep. How about it as decimals? To write a decimal as a fraction, what would you do? Jacob?
Well, so with normal numbers, everything goes into groups of tens.
Mm-hmm.
So you would the denominator, that would be a 10, and you just choose the number of the decimal.
Right. And wherever the number or the place that the decimal ends, that becomes your denominator. So 5/10 is written as 5 over 10. And then reduce it to 1/2. 4 and 363 thousandths becomes 4 and 363 over 1,000. So what we would do is read the decimal and then write the place of the last digit as the denominator. Now, you could also write the whole number as part of the numerator by adding the whole number to the top line. Instead of writing 4 and 363 thousandths, you could write it as 4,363 thousandths. Those two numbers are equal. And so we can write it just as a fraction that way as well. Okay? Now, let's talk about what an irrational number is then. These are all rational numbers that we can write as a whole number over a whole number. What about some irrational numbers?
For decimals, an irrational number is a number that just goes on forever.
Yeah, it just goes on forever in a random pattern. Like pi is an example. Okay? 3.1415 something, 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 something. Okay? And it goes on in a random pattern all the way to infinity. It's an irrational number. Some other irrational numbers are square roots of numbers. Does anyone know what a square root of a number is?
Yes.
So we've learned some square roots that's written with this sign. It's called the radical sign. And the square root of a number is the number that you would multiply by itself to get the number inside. So what number would you multiply by itself to get?
2.
You can multiply 2. Yep. So the square root of 4 equals 2. And the square root of 16 equals
8. Wait, no, 4.
4. Okay. Now, in between these, you have a number like the square root of 3. since that's not a perfect square, that number then is a irrational number. Okay, you can't take a terminating decimal and multiply it by itself to get 3. You can't get a number like that. Or if you put this number into your calculator, you'll come up with a random decimal that never ends. So these are irrational numbers, when you have the square roots of numbers that are not perfect squares. Yes?
So they're kind of like exponents, but backwards?
Yeah, it's like undoing an exponent. Yep. Undoing a power. Because 2 squared is 4, so then the square root of 4 is the base of what you would use to get 4. Okay? Yeah. Another example of irrational numbers. Okay? Oops, wrong set. There we go. Then, yesterday we also talked about numbers in between numbers. Okay? Now, go to your practice side. Numbers in between decimals, like in between 0. Can we find a number that's between 0.1 and 0.2, for example? What would we do to get a number that's in between these? They seem to be right next to each other if you wrote them on a number line, right, Andrew?
Yeah.
So what would you do to find a number in between them?
You just look between them?
Yeah, in between 0.1 and 0.2. What did we do yesterday? Do you remember?
Not really.
Okay, then pay close attention.
Okay.
Devlin?
0.15.
Good. If you put a 0 on the end of these and read it as 10 and 20, then that's exactly in between. It's 0.15. These two are equal. We can put a 0 on each one and still have an equal ratio, or we can, doesn't change the value at all even. Okay? And so we can then find numbers in between. Now, one of the things you had to do in number 14 on your assignment was find a time in between 30.2 seconds and 30.55 seconds. So, to help some of you with this, how would you find a number between these times? Maya?
We could put a 0 behind the 30 so then you could see what numbers between 30 and 55.
Yeah, right. These are equal, so we'd have to use 30, and then find a number that's between 20 and 55. There's an infinite number of numbers between every number. Think about that, how our numbers work. Okay? Yeah.
So Jacob's Pilgrim had numbers.
No.
Based
All right, let's move on.
And its weight.
Aiden, my turn. So in between here, you have 30.3, 30.4, 30.5, 30.51, 30.52, 30.53. All of those numbers to infinity
And beyond.
and beyond. Yes. Okay? Any questions about finding, listen, any questions about finding numbers between other decimals? All right. So that's a summary of what we did yesterday in lesson 10.1 on rational numbers.